Okay, Darren, you have the floor.
Thank you. I'll just maximize my presentation. Just give me a second here, guys. Should go to maximum right away here. I hope. What's going on here? There we go. All right. Good evening, everybody. As Mark said, my name is Darren Hennig. I'm with the RASC Winnipeg group here in Winnipeg, Manitoba, Canada. Welcome, everybody. I see we have some people on both sides of the border, mostly from the southern side. Welcome to all our friends in the US. And tonight I was asked by Mark to give my talk that I gave. This is a full talk compared to the one I did at RASC Toronto chapter several months ago. And so I've got some extra content that might be of interest to everybody here. So welcome one and all. And hopefully by the end of this talk, you guys will be thinking about getting some big binoculars. So we'll just jump right into it. I think all of us at some point in our life have had an epiphany. That's why we're interested in astronomy in general, whether it be as a very young person, or maybe a young adult, maybe on a camping trip with some friends or whatever. And we just look at the universe and want to reach out and get closer. It's just such a overwhelming and profound experience when you really get under a dark sky and get to enjoy it. And one of the nice things with binoculars is they really enhance our ability to dig into the sky in a very intimate way with both our eyes. And especially as we get to larger instruments, which we're going to talk about tonight, you actually get that little bit more intimate connection with the cosmos, kind of bridging the gap between a binocular and a telescope, but leaning a little bit more towards the telescopic side in some cases. So I think you'll find by the end of the talk here, that'll maybe instill some interest into, for those of you that don't have larger instruments. I always like to beat up telescopes when I do a binocular talk, so this is no exception. Whether you're a new observer or somebody who's a seasoned observer, it can be very daunting deciding which is the best instrument to go out and view the heavens with. Quite often, especially with family, we've had COVID the last little while. Working from home has created new family and work challenges in some cases. It can be really daunting when you get a sliver of time to decide what instrument you want to take out, and you may only have a half an hour or 40-minute window. Well, binoculars are a great way to go, and even big binoculars don't take much more than smaller pairs to mount and set up and start enjoying the heavens. And their cool down time is much quicker. So this tends to be a really, really good option for a lot of people that maybe haven't really thought about the portability aspect of these instruments. And they definitely dig a lot deeper than people sometimes imagine they do. So now when we get into larger instruments, I mean, this applies whether you're using a telescopic eyepiece or a binocular, large or small. But there's two parameters that are very important to consider, especially with a pair of binoculars, to make them comfortable to use. The first one is eye relief, and that's the distance, for those of you that don't know, from basically the top surface of the ocular lens that you're looking through, basically to where your cornea is. But technically, it's the minimum position that you need to be at to comfortably see the entire apparent field of view in the ocular. Okay, and exit pupil is another very important parameter that it's basically the diameter of the cylinder of light that's coming into your eye. Okay, so very important to consider those two things when you're getting an instrument, because you want the comfort, but you also want to have a best balance between capturing enough light and fully illuminating your pupil, of course, and getting the detail. And as we get to larger instruments, you're going to see that this exit pupil usually is a little smaller than what you expect for smaller handheld pairs. And there's a couple of reasons for that, not the least of which is just the optical design. But there are some huge advantages there. Now, for those of you that, I know there's a little bit of a different school of thought on both sides of this. There's a lot of people that believe that having as large an exit pupil as possible for an instrument like a large binocular has some advantages. But to be honest, usually you're not always able to get to a fully dark adapted, fully dilated pupil. And anything outside of your nominal pupil size is wasted light. Not to mention the fact that if you get a too close a match to your actual eye pupil, you have to be very, very precise on how you're positioning your eye, or you're actually going to lose light on one side or the other, or both, depending on how you're holding your eyes. So it can make it very metastable or very finicky in order to be able to use the instrument properly. That's why we usually get and recommend exit pupils that are significantly smaller than your large pupil with these instruments. For those I'm sure most people know this, but for those of you that, as a primer, that don't know how to calculate exit pupil, you just take the objective or lens diameter divided by the magnification. And so as an example, in a 20 by 80 pair instrument, you would use, you would divide 20 into 80, and that gives you 4 millimeter exit pupil. So that's the diameter of the cylinder of light coming out of the instrument. This also applies for telescopes, by the way, as well. So the same math applies in both cases, because effectively a binocular is a twin prismatic erect image telescope, and one feeding each eye. And that's really the nice advantage with these instruments. Now, because of the fact that a binocular often will be employed, handhelds especially, but even in larger instruments, you might also want to do double duty with them. You might want to use them for terrestrial observing. Maybe you have a cabin out on the lake in the summer and you want to take your, if you were to get a large binocular, you might want to look across the lake, see what's going on and so on. As a consequence, you may not always be using them exclusively for astronomy. This 20 magnitudes per square arc second works out to be about a naked eye limiting magnitude of 5.5. So that's sort of the regime. It's about 10 to the minus 3 candela per square meter. Anything below that, and you're pretty much into the scotopic range for your retina or dark adaptation. And that's where you're starting to border on a true dark sight, or starting to get there. I know there are some schools of thought on that as well, but that's sort of the sort of rough borderline. Anything above that, and you're usually in non-ideal illumination conditions. But because there are times when you're employing these instruments in other applications, or even dawn-dusk viewing, they really shine really well for those as well. You're not always at dark adaptation. So again, this is another reason why you don't want to have a fully dark adapted theoretical pupil size of, say, 7 millimeters or so. Now, there's kind of something interesting that goes on. Gary Saronic talks about this. He's an RASC member of Vancouver Island, I believe, and he has a website. This particular slide is not from his, but this is a typical scatter. I just put this up for people to copy the link if they're interested. This is a typical scatter plot. There's been many studies done over the years of exit pupil, or I shouldn't say exit pupil, sorry, fully dilated pupil size versus age. And you can see how it does follow a general trend, but it's really very, there's a lot of scatter there. The only trend you can really say is somewhere around our mid to late teens and possibly early 20s is where we get the maximum size for the pupil. And anything outside of that, we start to slowly get smaller and smaller. But you can see even on this sampling here, people in their 60s and 70s, some of the population are still well above 5.5 or 6. So what does that say? It really says that you can't make a general blanket statement as to what your dark adapted pupil is. You'll have to measure it in some form. But suffice it to say, with these big binoculars like the 20 by 80 pair that I mentioned earlier, we're sitting right around 4 millimeters. And you can see here, if I overlay it on this plot, pretty much 95, maybe even 98% of this population, well into their mid-senior years, can easily accommodate this instrument. So that will not be a limiting factor for them. And that's a very important thing to take away when you're considering an astronomical instrument that you can use for many, many years. It's nice to be able to use it without any possible restrictions. Obviously, there's genetics and other things that come into play here, but generally speaking, I think you can see from this limited sampling, which is probably very typical, we can definitely accommodate people very well. One of the nice things about having an exit pupil in kind of the intermediate range is it's the best balance of factors such as sharpness. Those of you that do photography know that the center part of a lens, when you're shooting, if you stop down your lens, you get the sharper images than you do if you open it right up. Same thing with an exit pupil here. If I'm employing the entire lens of my eyeball, I end up running into aberrations as well. And therefore, that becomes my limiting factor in the instrument, not the instrument optics themselves. So having sharpness and a balance between largest practical pupil and brightness is very important. And I just like to, the reason I wanted to emphasize these things is because they're things that people don't always think about when they're employing their eyes into a binocular instrument. And I think it's really important to address those things, okay? So as you can see here, we're going from varying size ranges here, and having an intermediate one kind of serves the best of all worlds, as it were. Another thing that a lot of people don't think about too much or pay much attention to, or maybe they've come across this in their past when they're employing even smaller handheld pairs, is the interocular distance. And none of us are, or very, very few of us are perfectly symmetrical. So you can see here, there's an example of somebody who has a slight asymmetry between their eye and the center of their bridge. And that plays a role as well when you're trying to center your eyes into the view. And another reason why you don't want to have a large exit pupil, because you might have trouble actually fitting your eyes perfectly onto the instrument, square on in some cases. These are my numbers here, and I have about a 1.5 or so millimeter difference between my two, or 1.4. And as you can see here, that translates to about 1/8 of an inch. It's very small, but I do notice that I do shift over a little bit to the right to make sure that my eyes will properly center on the instrument. My spacing is about 63 millimeters. Some people will be wider, some will be narrower, some will have fatter bridges, some will have narrower nasal bridges. And those all come into play in comfort, as well as being able to properly center your eyeballs onto the instrument. So these are things that you need to evaluate for yourself before selecting an instrument, or if you have a series of instruments, maybe play around with them a little bit more, fine tune them, make sure that you can get, if you're not mounting them, maybe even mount a smaller handheld pair that you may have right now, and use this type of approach to get optimal comfort. And once you kind of know where you need to be, then when you start getting into a larger pair, this will be even more significant, because obviously you've got larger magnification, larger apertures. So any little minor anomalies are going to be amplified that much more with a higher power instrument. So just something to keep mindful of as well when you're considering selecting an instrument. Pardon me. Another thing that does crop up from time to time, very rare. We have one member that may be right on the edge of this. He bought a pair of 15x70 overwork binos a couple of years ago on my recommendation. And he's been really having trouble with them. And he thought it was something wrong with the binocular, but it turns out he's got a slight, a small amount of displays. I can't even read that here. I can't remember what it's called. Dysnomia, I think it is. Anyway, basically you have trouble with overlapping your fields of view, or sometimes you might have a minor cross-eyed field of view where it becomes hard to merge the images. Very rare, but if you do suffer from this, if you've employed binoculars in the past, what you need to do is have a close friend or family member or fellow member of your club look through them, set them up for themselves. If they're not experiencing the same trouble you are, go and see an ophthalmologist, because if it's just started to develop, you can usually get it corrected with, in some cases, medication or exercises, and it might have to be surgery in some extreme cases, but it does get worse with non-treatment. So it can really cause headaches and other things, especially nowadays with everybody on screens. It can be a real problem. So definitely get that looked at, because it's nice to be able to enjoy both your eyes together. Well, let's get into the meat and potatoes. Enough about exit pupils and stuff for now. Well, it's all really about image scale and why we like to use binoculars in general. Normally the handheld pairs, we like to take advantage of the fact that we get a much more generous field of view than you would with a telescopic view at high power. So I've got an example here of a coin on a table. We can pretty much read the coin, but now if I do a big binocular type view, you can see I still retain the context of the wooden table. I can definitely see much more detail on this coin and the grain in the table, but I haven't lost perspective that it's a coin on a table. Obviously, this is an extreme situation, but if I had a high-powered telescope where I couldn't go very wide and I'm looking at a more extended object, you can see here if I had started left to right instead of right to left, you would end up having a real tough time guessing. You'd probably guess it's a coin. You might guess that instead of the table being a table, it might be a rock face or something. You don't know. So again, there's times when this intermediate perspective holds a lot of power in being able to not only identify and enjoy the surrounding of the object that you're concentrating on, but still be able to get a little closer, but not too close. And there's countless clusters and some larger galaxies and stuff that really benefit from this type of approach. So what is a big binocular? I mean, the talk here today is big binoculars. What do I call a big binocular? Well, pretty much anything in 70 millimeters and up. Normally I would have selected 80, but there's a reason for picking 70. And I'll just mention that because there's two different types of instruments. The binocular telescope designed for large binoculars start at 70 millimeters. You can get them 70 millimeters and up. So I thought 70 was a good sort of borderline. So if you have 15 by 70s, you're kind of right on that fringe area where you're into the bigger binocular for sure. And these often have low to medium powers, usually 15 to 40 powers. Some will even have variable power capabilities. And they're normally mounted for best results. So really in a binocular that's got at least 70 millimeters or more, they're really not hand-holdable instruments for any extended period of time. There are exceptions to that, but even a lightweight 15 by 70 pair, over time, you're still having a little trouble getting the full capabilities of the instrument by trying to handhold it. It's really much better mounted and stabilized. So there's several advantages for big binoculars over the smaller cousins, I guess, or little brothers and sisters of them. First one is these smaller exit pupils. You get the sharpest portion of the eye. We already discussed that earlier. That's why I went through that. You get a stereoscopic 3D erect image view. And I think that's a very important thing. I mean, we're all familiar with that, but there's some subtle nuances that are actually quite significant about that. And I'll talk about that a little later on. We also have more power than we do with the smaller instruments, which still leave us with very rich fields of view, but with a lot more detail. And I have some slides later just to kind of address that in a more illustrative purpose or process. Also, the image scales for many targets, specifically larger galaxies, extended star clouds, the moon and the sun, really significant when you're employing a larger instrument. It also applies to smaller instruments, but it starts to become really noticeable when you up the game to like 80 millimeters and up, especially. You start to really see this effect quite much more. And it has to do with our eye-brain system. We'll talk about that in a few minutes too. The moderate weight still makes them very portable. 13 pounds would be kind of a more extreme end for some of the instruments that I'm talking about today. Certainly in the 110 millimeter and down, this would definitely apply. And quite frankly, they're just fantastic. I mean, I've been doing large binocular astronomy now for coming up on just under 10 years. Had I known I was going to have so much fun, I would have done it 2 decades ago. I'm not kidding. I've always had at least a 70 millimeter pair in my arsenal in the last 25 or 30 years, but even going larger than that with higher powers, it's just so much fun. I'm going to stop here for a moment and see if there's any questions. I'll probably be addressing some of them later, but go ahead, please. Anybody have any questions up to this point? I guess not. Okay, I will carry on then. Thanks, guys. All right, so there's 2 different types of big binocular formats. The first one is fairly well known. I know we see these a lot on ads, Orion, Celestron, and so on. There are other manufacturers as well that make these. And these are basically, again, like I say, the large cousins to the smaller pairs that we're more accustomed to. They're the straight through Poro style binoculars. There's several advantages to having this particular format. The first one is it's very easy to use, and we're very familiar with our handheld pairs, so there's really not too much that is different from them other than they're just larger and slightly heavier. They're really shine for terrestrial viewing because you're looking straight through, as well as lower observation observing if you like to watch dawn dusk planets or look at things rising, or you have things low to the horizon that you like to pan through. The straight through view is exceptionally good for that. It doesn't shine as nicely for overhead unless you happen to have a particular type of mount or are reclining in a chair with like say a parallelogram mount or something like that. Then you can still enjoy them very, very nicely. And most of them up to about 100 or 110 millimeters are easily mountable. They usually employ a central stalk. There's a dual hinge connection because you can imagine these lenses in the front are very heavy. And especially when you get in beyond 80 and above, it could put a lot of stress on the rear hinge. So quite frequently, they'll have a double hinge with a sliding rail where you do the balancing for the instrument. So really nice way to be able to set them up and use them. They also come in both an individual focus and, well, not all of them, but there are pairs in the size range that come as individual focus or as a bridge focus, like we might see with a 10 by 50 pair, say, as an example. I do recommend going with the individual focus pairs because you can really dial in for both eyes. And especially when you start getting subtle changes in temperature, this becomes even more significant. You're tuning to each eye individually. Makes a huge difference when you're trying to dig out fringe observing stuff or just that last bit of detail. It's really quite neat. Wide range of sizes available. It's also the most cost-effective way to get into this size of observing with two eyes. Really, really nice way to go. I started out with a 25 by 100. It was my first big bino, and I'll talk a little bit about that later, but had years of fun use with it before I sold it to a friend of mine. And sometimes I even miss that pair. It has a little bit of a sentimental value to it. I did a lot of firsts with that in binocular observing, so it's kind of fun. The other format here is the binocular telescope style. And as I say, 70 millimeters is usually where they start, but they can also get up to the big comet killers, the 150 millimeter twin binocular sizes that you might see that a lot of the Japanese will use as an example for comet hunting. And there's no accident why they do that. The two-eye view and the tremendous huge contrast that you have really allows you to dig through a lot of very dim objects, even in what would be considered fairly significantly bright areas. I'll talk about that a little bit more too down the road. These binocular telescope styles are basically available in either a 45 or 90 degree design. It really depends on personal preference. I like the 45 because it's sort of a best balance between the two. And the nice thing is, looking downward at, towards the horizon, you're only looking down 45 degrees. And if you're at the zenith, you're only looking up 45 degrees. And it's very comfortable for the most part. I find that the 90 degree ones are a little less comfortable myself, but of course I do have telescopes with star diagonals and I'm used to doing that. Just that I find with binoculars, it's a little bit more comfy, but it's totally up to you. They're mountable on heavy photo or video tripods as well. Often many of these will come with fork mounting options as well. And one of the advantages to this that you don't see with the straight through as often is the ability to replace eyepieces. So these are basically twin prismatic telescopes for real with a unibody and side by each. And so this has some huge advantages if you're wanting to get a closer look at craters on the moon, say, as an example, or looking at planets and trying to pan around as you're getting into darker evening. You might be able to catch a nice moon transit if you're running a little higher power, just like you would employ with a, say, a small refractor or medium-sized refractor. So there's a lot of really neat things that you can do with these. Now, as far as mounting, there's several ways that you can mount these binoculars. The tripod mounting, I think a lot of people are very familiar with already. You usually get a decent video or good alt-as pan head. And then as long as it has the capacity to hold the instrument on there, then you're absolutely fine. You do need a higher end tripod and pan head in order to employ these larger instruments. Even if you're just going up a little bit, if you think down the road you're going to get a larger instrument, make sure that you have a heavy enough one to accommodate you. Otherwise, you will be buying a larger one anyway. The fork mounting is quite common with, as I said, the binocular telescope designs. Pardon me. And you can see the advantages there. You have a whole range of different degrees of freedom there for getting up to the zenith and adjusting the viewing position for comfort. A lot of fun, a little bit more expensive mounting scheme as well as instrument, but they offer some of the best views that you can get in this kind of format. It's really a lot of fun. Of course, parallelogram mounts are fantastic for both the straight through and even these binocular telescope designs, although usually most people use them for the straight through poros because they're already employing them maybe with smaller pairs. And you have all the advantages that you have with those as well. You can get right under the zenith, get under them to look right at the zenith. You can drop the view down so somebody shorter than yourself can enjoy the view of what you're looking at as well, or employ a nice chair comfortably if you want to pan around closer to overhead. So there's varying advantages and disadvantages for these mounts, but I think I just wanted to address these are the types of mounting schemes that are very common. As far as the parallelogram mounts go, There's some really good ones out there. I would say the UBM mount by Farpoint is probably one of the better ones. This one here that's in the picture on the right is the Orion HD Paragon. So it's able to handle about a 10-pound instrument. Same thing with the UBM as well. Both are very portable and easy to set up, and they stabilize the binos very well, even in moderate winds. Really a lot of fun. With the pan and parallelogram mounts, as I mentioned, you want to have a heavy duty enough tripod to be able to hold these instruments properly, particularly if you're going to do a mixed bag of terrestrial and other observing. You're going to want to have at least a 1.8 to, in some cases, 2.5 meter maximum height for the tripod. One that comes to mind is the Manfrotto 028, has a crankable column and a dual split leg that can go as high as, I think, almost 8 feet. It's pretty tall, but if you're, let's say, 6'2" or 6'3", it doesn't take long to require that extra height if you have a larger instrument like a 25 by 100. They're fairly long. You'll also want to have at least, I know I said greater than 25 pounds, certainly in the 18 to 30 pound range is ideal, mainly because you have to consider the load that you have on it. And you want, if you have a better load to capacity rating, just like with a telescope mount, you'll have much fewer problems when you're trying to aim and use it, as well as stability issues. When you happen to bump the instrument, it'll come back to equilibrium much quicker than it would if it was undermounted. Quality materials, as with anything else, makes a huge difference. Besides the Manfrotto, I know that Overwork makes their 5000 series tripods are very nice. And they also have a really nice wooden tripod with a carbon fiber column that you can adjust up and down as well and mount a pan head or something else on. Those work very well as well for a platform here. They're not inexpensive, I won't lie to you. You're probably looking at anywhere from, say, $180 on the low end to maybe about $400 on the high end or somewhere like that. But it's a good heavy-duty utility tripod, always pays big dividends. There's always use for it. Besides the binoculars, you can do other things with it too, but certainly you want to stabilize them very well. So this is just more for a tongue in cheek here, but I found this online and I just couldn't resist. Basically, it's just something to be mindful of when you start getting into the larger instrument regime. Obviously, telescopes have their own stigma, but most people assume you're going to be looking at the night sky or at something aloft. Binoculars, of course, have that spyglass sort of stigma to them anyway at the best of times. And you can imagine a mounted instrument, a larger mounted instrument on a tripod in a backyard looking over a neighbor's roof might look a little daunting if they don't know that you're doing that. Even if they know you're an astronomer, they might forget for a split second. So just make your neighbors aware when you're doing this, that if you are in a more suburban setting, hey, I'm harmless. I'm just looking at the moon. If it happens to be just over your roof line, please don't worry. I'm not checking you out. I know it's a silly thing to say, but it's important, you know, because you don't want the local constabulary or sheriff showing up on your doorstep asking you what you're doing. Usually what'll end up happening is you'll show them the moon and he'll go, that's really cool. Okay, thanks. And off they go. But still, it's things to be mindful of. So we were talking about some of the advantages here between different pairs. And you can see here how an 8x42, which is a fairly common smaller handheld pair, you get a very generous field of view in the sky. Well, when we look at a larger instrument like a 20x80, say, it still has a very generous field of view, 3.1 degrees, which translates to about 6 moon widths, roughly, just a little over 6 full moon widths, which is still a lot of sky if you've looked at the full moon here recently, the last couple of nights, and just tack on 6, that's still a lot of sky. But you can see here on M45, the Pleiades star cluster, we're getting much more intimate with the object, and we can start to see tighter doubles in the cluster. We can resolve some stars that maybe weren't resolvable at the lower power, but we still retain the context of the object that we're looking at. And that's the big plus here with these instruments, as I said before. So I always find it very sad in a way that a lot of people make apologies for binoculars in a way in general, treating them as, well, if you can't afford a telescope, get a pair of binoculars. You can still see stuff. You know, for those of you that maybe already have good quality smaller pairs, there's sometimes no substitute for these instruments. They go a long way and there's a lot of bang for the buck. And I know I keep hammering this point home, but even when we get into the bigger binoculars, we've really bridged the gap between a lot of these objects that you can see with smaller handheld pairs versus telescopes. And it's really quite amazing when you start employing, say, 100 mm class instrument, how deep these really dig. And we'll talk about this right away here. But instead of saying you're halfway to a telescope, I'd say you're like 3/4, 2/3 at least, but 3/4. And you can see here on this diagram to the upper right, the telescopic field, especially a high power SCT, even if you're going wide field, you might have a tough time squeezing that object in, but you can frame it beautifully in a big binocular, but you're getting closer than you can with a smaller binocular. So there's some real big wins there. So here's some of the objects that I mean, this is just a smattering, but double stars. I mean, there's a lot of moderately tight doubles that a large instrument in the 80 and 100 mm class can easily resolve with decent optics. Carbon stars are a lot of fun. The brighter ones really show up nicely and pop beautifully against the celestial tapestry, just look like little burning coals in space. And because I'm not sure for many of you, but I always find the color rendition in most good quality paired binoculars just so vivid. And I think part of it is because you're employing your two eyes too. So it's really quite amazing how much subtle changes in even just the tone of stars show up in a cluster. It's really quite pretty when you get good seeing. It's amazing. Bright asteroids, we have many that come into opposition quite frequently, and even some of the dimmer asteroids with larger instruments in a dark sky, relatively easy pickings for those instruments. Daytime planetary observing, one of my favorite things to do. I've been doing that for over 25, coming up on 30 years now. And I'm not talking just dawn and dusk, I'm talking midday. Even with a handheld pair of 10 by 50s, you can see Venus as a crescent, no problem. But as an example, in November, just before the occultation, I had my 16 by 70s out, and I was looking at Mercury's disk midday at 16 power with a 70 mm class instrument. It was 17 degrees away from the sun. Now I was in the shade, like I went into a shaded portion, and I'll talk a little bit more about the occultation a little later. But it was actually not as hard as I thought it was going to be to find it. And I've found Mercury before with binoculars, certainly at dawn and dusk, but seeing it midday, I hadn't really bothered. I'd mainly done telescopic, but I thought I'd try it for a lark because I knew the occultation was coming up, and I was amazed how easy it was to see even in a 70 mm instrument. It didn't just jump out at me by any stretch, but it definitely was visible. So it's kind of neat. Small, but visible. Just the fact that you're looking at that is kind of neat. Lunar and other occultations, really fun to follow with binoculars because you can catch them very easily. And the nice thing with the wide field, again, you've got the moon passing through a star field. So you still get the benefit of seeing the occultation, but especially in a denser cluster, you can see a bunch of stars at any given time winking out, and the moon actually moving through the cluster, which is really neat, especially if you haven't done anything like that before. Solar and lunar observing, believe it or not, large binoculars show a heck of a lot of detail on the sun and the moon, a lot more than you'd think you'd be able to see. If you use a quality full aperture filter on these, you can see subtle granulation, sunspot detail that can change even in a 20-minute period in some cases. Certainly higher power is easier to discern this, but it's really quite amazing. Even little micro spots will start to show up in the 2 arcsecond range, even at the lower powers, like in the 20 to 25 power range. They show up very, very well, as long as you have good vision, of course, and good quality optics, and you've got them dialed in properly. You should have no trouble seeing those kind of things, faculae, granulation, and so on. Obviously, for lunar eclipses, as an example, a lot of people will like to employ telescopes, and it's kind of neat to see the umbral shadow go across and kind of slowly darken things. But I always found that when I'm using a telescope at too high a power, you tend to blur out things because there's not a lot of light there as things start to, even the deep penumbra sometimes will blur or obscure things. I find it much easier in big binoculars to look at lunar eclipses, especially close to totality. Really, really pleasant to view that way. General lunar observing, I mentioned already, so we'll get back to that later. Star clusters, a lot of fun. In fact, there's some objects like the double cluster in Perseus, beautiful object that frames exceptionally well in virtually any instrument, but certainly the big binoculars really show the expanded surroundings, and you just fall into the stars. Dark nebulae, that's a fun one for me as well. I had my 82 millimeter APM binocular telescope out this fall, or I guess late summer, early fall, with a few friends, and I was banging off about, I don't know, 24 dark nebulae. It wasn't even hard from a dark site that we were at, and it was a lot of fun. 82 millimeter twin binocular telescope, and I'm seeing these things very easily. Some of you have probably seen these in Dobbs and other things, but when you're thinking about what you're using in the aperture range, it's really quite interesting how much more you can see, or how deceptively more you can see, given that you're using a certain aperture range. It's kind of weird. Also, satellite passes. One of the beauties of binoculars is it's easy on an Altaz panhead to just go, you don't have to worry about polar alignment or anything. Sometimes you can lead the ISS or some other, I've had it one or two times where I've followed the Starlinks getting deployed. I know I'm not necessarily a big fan of having a bunch of satellites obscuring our sky either, but they are neat to watch as they're deploying, that's for sure. Bright near Earth objects, down to about 12.5 magnitude for some of the larger instruments. You could see on a closer pass of a slightly larger or brighter object. Comets are another area where these really shine. Neowise, a lot of us looked at Neowise last year, and Neowise was fantastic in large binoculars, just superb. You got a good chunk of the tail, plus really good coma definition and nuclear definition as well. And as it bifurcated, you could really see that nicely in a 25 by 100 instrument. So really all the benefits that you have with a wide field telescope, or even a modern aperture telescope, you can actually see in a lot of large instruments like these big binoculars. Really nice, really nice. I'm going to pause here for a minute and see if there's any other questions.
And just a reminder, if you have a question, you'll need to unmute yourself.
Excuse me. I guess there's no questions. Okay, either I've totally perplexed people or bored them to death. I'm not sure what, Mark, but we'll carry on.
Oh, hi, this is Felix. I was muted.
Oh, hi, Felix.
I'm sorry.
No worries.
And thank you. This is really interesting. I don't know if you're going to discuss it, but on the mounts, and I'm only using a Nikon pair of 10 by 50s, and I started that because it was recommended on cloudy nights to start with binoculars, which I did for about a year. Okay. I got the Orion parallelogram that is it not the HD model, but the
Paragon, model. The standard Paragon.
The Paragon,
yep. Okay.
Right.
Yep.
And so it's meant for using directly, but I actually got a gravity lawn chair. So I'd like to put it to the side. Do you have any recommendations as to an adapter to use for that?
I know what you're saying, because those ones you're looking straight over the arm, aren't you? And in order to try and if you tried to sit in a zero gravity chair with those, assuming you could, yeah. You're going to have a bit of a difficulty, because that back leg is going to interfere with you'll be a captive audience until you figure out a way to get out of that. Yeah, I see what you're saying. Ideally, you want to do it to the side, right?
Right.
I do have a couple of ideas. I'm going to give you my email, or I'll have my email address on for at the end of the talk here. So okay. Copy it down, send me an email, and we'll talk offline on that. And okay. I'll send, if it's okay with you, when I reply to you, I'll send Mark a copy so he can share it with the people who've attended today, just in case they have something similar that they'd like to ask. That way we cover all the bases. Is that okay with you?
Sure. Thank you very much. I appreciate it.
No problem. It's very we'll get that figured out for you. I have a couple of ideas. We have the same challenge with one of our club mounts that we use for a loaner, like we have a loaner program. And on the binocular one, we have one of those Paragon mounts as well. And there was one pair of binoculars that would have been easier to mount sideways on it rather than straight across. And so we're coming up with a solution with that for the spring, because we're going to have a lot of people wanting to do the same thing, be able to mount their binoculars and try this mount out before they get their own, right? So yeah, we'll get you set up. Don't worry.
Thank you very much. I appreciate that.
Thanks for the question, Felix. Appreciate it.
All right. Thank you. Bye.
This isn't really a question, just an observation. After doing years of telescopic and with a really nice, a range of binoculars, but you talk about the double cluster. with like the TV 101 and a 31 millimeter Maglev Type 5, it just was never really that impressive of a view. But then when you look at it with 100 millimeter binoculars, like I've got a 100X LSD, it just blows you away. The difference looking at that thing with a large binocular is astonishing compared with the telescope.
Yeah,
there's something
I'm going to be talking a little bit more why that is the case in a few minutes, Fisk. So no worries, but I appreciate your comment on that because you're absolutely right. When you think about a wide field, even a high-end wide field refractor, sometimes it can be still impressive, but then you get that twin binocular view and it just comes to life, right?
You know, it's hard to stop looking at it, to tell you the truth. It just mesmerized me almost. And larger kind of clusters and things like that, where the binocular really comes to the fore compared with like a telescopic observation. You do a lot with them, of course, but in like with something like the double cluster, you just haven't seen it if you haven't looked at it with a large binocular. It's amazing.
Oh, it just opens up that I know, and there's other objects like that too. I've never gone down under, but I would love to check out like the Gold Sack and Omega Centauri. That would just, I mean, some of you folks might be in like Southern California or even Texas. I don't know how many people we have online today, but they may just barely get bits of some of those objects. But I would love to go down south before too long and actually take a couple of my pairs. I would just take the binoculars. It would just be so much fun.
Or just roaming the summer Milky Way with them. It's such a different experience than telescopic observation. It's remarkable. It really is.
I appreciate that. And we'll talk more about that afterwards. So certainly if there's any other comments you want to bring up, Fisk, please feel free to do so. Thanks for your comments on that. I'm glad you emphasized that because it really is true. It's hard, and it's even hard to describe to somebody who's never looked through an instrument like this, what experience they actually, I had no idea till I got my first pair. I just about fell out of my chair when I first looked through, like you say, the double cluster or something. It was just so jaw-dropping. All right, well, we'll move on then for now. Thanks again. One more question, if anybody has one or a comment. Okay, I'll move on then. Thanks, guys. All right, let me just fire up my thing here. So besides the, one of the things that we were talking about, clusters are one area where these things really shine. And another one is, I think I'm locked up here. What's going on? Let me just see if oh, there we go. Sorry. I was just wondering what was going on here. Another area where these kind of shine a little bit. They're not as impressive as the telescopic view, I'll be honest, but there are some times where these just really are nice to employ when you have limited time or you're just trying to follow the positions of certain planets during the day or non-dark hours. Venus is obviously a very good one because it's very bright at the best of times. And even with a smaller, like 50 millimeter class instrument, I mean, you can see Venus in the daytime almost always, except for when it's very, very close to the sun. Then you need to be a little bit more careful, but it's pretty much available within a wide range of its orbit. And you don't necessarily have to do dawn and dusk for this. But this is sort of a typical view you might see in a medium power binocular. And as you can see here, I mean, you're actually you can see the phase, and Venus is so bright anyway, unless you're employing specialty filtering, you're not really going to see a lot of detail on Venus. But to give you an idea of what's possible, even a 16 by 70, I've got a pair of 16 by 70 APM MS binos. I've actually 2 years ago during just past the Mars opposition in the early fall, in late October, early November, I was actually looking at Mars in the mid-morning. So the sun was already up, but it was behind my neighbor's house, so it wasn't interfering with me. And I'm looking to the slightly southwest, maybe about 25, 30 degrees up. And I could actually pull out well, these things are razors anyway, but I could actually pull out the polar cap and I could see it was Syrtis Major was just happened to be in line, just barely pick it out, but it was there. And, when you're looking and thinking about the power and what you're using, it's kind of weird to think that you can actually pull that kind of detail out with that. Now, I've been doing visual astronomy almost all my life, so I've got a lot of practice, but I'll have a friend of mine, James Fast, come on after we're done with the Q&A just to talk about his experiences, because he's a fairly new member in our club. but yet he's got very good eyesight, and he's seen some of the advantages I'm talking about here as well. Anyway, moving on. Jupiter, you can see belt banding very easily in the daytime as well as dawn and dusk. And Mercury, I'm going to talk about the occultation in a few minutes here. Saturn, you have to be a little darker typically, but it still is a lot of fun to do as well. Now, this is a slide I did on an original binocular talk back in 2018 when I was doing an introduction to binoculars, but I have a pair of 10 by 56 DCFs that I just happened to have out that night. And you can see here how this is the sky on the 21st of September in 2018 for us. And what was really interesting in this particular situation was Saturn was in the same region of the sky as Vesta. Vesta was going through kind of its brighter period near closest approach to us, and it was really good opposition, I guess you could say, or not quite opposition, but it was certainly near its perigee, so it was a lot easier to see, and it was definitely within the range of even a smaller pair like a 10 by 50 or 56 pair. And all I did was just put Saturn just outside of the field of view slightly, and Vesta was right in the middle, just a bullseye. Now, to double check this, I ended up using my Overwork 25 by 100 individual focus deluxe binoculars, and I started with Saturn and star hopped down to this cluster here by 9 Sagittarii, and then just dropped it to the so Herschel 36 was just starting to come out, and we're talking like a half an hour, if that, after sunset. So this wasn't even dark sky yet. I know it looks dark here, but it wasn't even this dark yet, and things were already starting to pull out of the tapestry, and especially with this the twin hundreds. I mean, it was really, we were already seeing quite a few stars in the cluster. Anyway, dropping down, I mean, I just was able to put that to the 12 o'clock position, boom, confirmation of Vesta for sure. And it wasn't hard at all. But even with the 10 by 56 pair, a lot of people don't realize what they can do with a small binocular if they mount it. And so this is really important. I mean, these were obviously mounted in both circumstances, but really important if you're trying to do this more advanced observation. Let's face it, unless you have a 24-inch telescope, Vesta is going to be a small point no matter what you do. You might get hints of a disk even at a 14-inch instrument and higher powers, but how often are you going to be able to really, you're not going to see any detail as a rule. I mean, it could be wrong, but generally not so much visually for sure. So there's no real point. Same thing with the gas giants, unless you're doing some high-end observing on the gas giants, they're pretty small discs. So again, binoculars are really good for those. This would be more of like a 30 power range with say a twin binocular telescope. And you can see the moon is still, this is reminiscent of like the panoptic or yeah, let's say a panoptic in a TeleVue 101 type of view. And, you know, you've got, you know, still a fairly extensive field of view here. We're just shy of 2 degrees or in that range. But the moon still is sufficiently large, and it's amazing the amount of detail you can dig out on the moon. It's absolutely jaw-dropping sometimes. I know, you know, when we're talking about clusters, it's actually kind of surreal in a way because you're using 2 eyes. And I'm going to talk about that in a few minutes here, why this is so significant. And it's a subtlety that a lot of people don't appreciate. Solar, yes, it's still a small disk, but look at all the detail here. This is just sort of a typical view. This wasn't shot through any of my instruments. I'm just using this to kind of frame what you're seeing at kind of a medium to medium low power. You know, this is the kind of thing that you can expect to see. And there's a lot of detail there, even though it's small. You can see granulation, plage, you know, some sphaculum. I've actually caught a couple of white light flares in the past when viewing with binoculars with full aperture beta film. I'll talk a lot more about solar filtering later, just in the accessories portion. But even though it's still a fairly small view, there's a lot there that you can see, especially when you're you know, using a quality instrument. Now, this, I forgot to change this slide. I shouldn't have talked about today. This is when I did the talk the day that that we had the occultation of Mercury. So it was kind of fortuitous when I did the RASC Toronto talk. I'm sorry, I missed this before I did that. But basically what I did here, I live in Winnipeg. So we had an opportunity to, the moon and Mercury were about just shy, it was right around 15 or just under, between 14 and 15 degrees away from the sun. And after having bagged Mercury a couple of days prior with my 16 by 70s, I pulled out my 25 by 100s. Now I happen to have a gazebo that occludes the sun, and I can park my instrument behind that. And I just used an Altaz pan head with a heavy duty tripod. And it took a little while. I used an inclinometer to get my altitude right. And I have my all of my instruments, including my handheld pairs, marked for infinity focus. Very important if you're going to do this kind of observation, especially this kind of fringe observation where you've got, less than a 2% illuminated crescent and a tiny planet like Mercury that you're trying to dig out of the sky during the daytime. But I was able to see it and follow the occultation at least about halfway through. I was working that day, so I took an extended lunch, but I was working from home that day as well. So it allowed me to at least catch the initial part of the occultation, but obviously the reemergence I didn't have time for. So and it just didn't work out that way. But still, being able to catch it in a pair of binoculars, I know there were several of our club members that were trying to catch this during the day with telescopes, and some of them had some real tough times. There was one other fellow that employed a telescope, but he started at dawn and did tracking all the way through, which was pretty smart. But I found it dead reckoning pretty much. All I did was use an inclinometer, and I'll talk a little bit more about that in accessories in a few minutes. But, just even if you think about it, who would have thought, right? Kind of a neat observation to do, especially with it so close to the sun. But this is the kind of power that you have in front of your eyeballs, as long as you're careful. Obviously, in this particular case, you can actually have a lot of fun with these things, a lot more than people think.
Yeah,
So a lot of people ask how deep these things can go. And it's really quite interesting because there's a lot of factors that play into it. Some of the more obvious ones, before I give an answer or kind of an approximation, is obviously the visual capabilities of the observer. Experience holds a huge factor in this quite often. A lot of us that have done dark sky observing for many, many decades will probably have a much easier time getting to kind of the closer to the edge of the capability of the instrument than somebody with a little less experience. Not always, but certainly that's one case. Age is a factor too. Obviously, a young eye will often be a lot fresher in some cases. There will be other things too, like diet and fatigue and so on. The altitude of the object above the horizon and the transparency and darkness of the sky obviously come to play. But as a rule of thumb, after that long preamble, I would say on average, you're going to get about mid-6s of gain. So if, let's say, you had an ELM of 5 and you were employing a 25 by 100 instrument, for a fairly typical or slightly experienced observer, you should be able to get just shy of 12 magnitude, in the mid 11s for sure, very easily. If you're at a dark sky where you're pushing ELM 6 or 6.2, you should be easily almost at the regime of 13, ideally, for a person with some decent eyes and a decent quality optic. That's not pie in the sky. That's absolutely like that. That's really what you can expect. 20 by 80 pair, maybe shave off a fraction of that, maybe 0.3 to 0.4 magnitudes. So you might be kind of in the low to mid 12s instead of bordering on 13. But that's the kind of power that these instruments have. And even when you think about it, even a high quality, 4 or 4.5 inch refractor employed at higher powers, you're still only limiting at around mid 13s, maybe at best, or high 13s. So you're really not losing a lot with these type of things in some cases. So I know that we had some comments about how much these objects pop, and there's some significant reasons for this. First of all, the advantage of 2-eye view, I've actually got a little bit more to talk about this in the next slide, but first of all, you get better light throughput because each eye gets some light than you would have if you, let's say, employed a bino viewer on a standard telescope. You also get a much more 3D depth, even on more distant objects. Obviously, our depth perception starts to drop off as the object gets further and further away. We're not seeing quite as much of a 3D effect, but our eye-brain system takes over and adds that in as an artifact because we're employing 2 eyes. But the fact that we're not splitting the light up into 2 independent paths and then going ahead and doing this has huge implications for us, because we're actually employing twin systems to feed each eye individually rather than splitting the light from one instrument. And that means you're going to see darker than you would on a single instrument anyway. We also get more detail, in some cases up to 40% more detail. I'll talk why that is on the next slide. Better dim light response. Again, the 40% factor has to do with sampling and so on. Larger image scale, I say usually around between 25 and 30% over a single instrument. So as an example, if I had a 100mm refractor running at 25 power, even a high-end one, and then look through a 25 by 100 pair of binoculars, say on the moon looks so much more alive, just like the clusters do in the binocular, than taking all other factors out of things. The image scale, your eye brain system synthesizes it, and it really adds to an effective enhancement in your perceived images when you're viewing through these instruments. And you see a lot more for a given aperture of instrument and magnification than you'd expect. So plus it's a rect image, so you don't have to do any mental gymnastics. So there's kind of no reason, there's no accident why a lot of binoculars are in that 60-degree apparent field of view range. When it's employed for terrestrial or general purpose, it matches very nicely the binocular field of vision where we employ our full 3D vision. We still have peripheral vision outside, but it starts to wane off after beyond about 70 or 75 degrees. So there's no accident that the vast majority of binoculars will stay within that for the two eyes to be able to perceive this, especially when you're doing terrestrial, where it's more significant to have the 3D view. But the other thing that's very important here, and this is why we see more with the binocular, is there's three factors going on, but the two that are really significant, I think, are the statistical summations. So for object to low visibility, we actually have a 1.4 times or root 2 statistical advantage versus a single eye, because we have twin detectors operating at the same time. So the chances of a photon hitting one or the other eye is more than one eye alone. So automatically we have the ability to look slightly deeper, okay? Also, there's a physiological summation. We actually have signals from each eye are added in our wetware, and our wetware is actually, our eye brain system is one of the most powerful image processing systems we know of. We're getting pretty close with some of our artificial ones, but there's still some things that visually we have some advantages on. And so as an example, being able to sum the signals from our eyes in real time and null out random noise partially means that we actually see deeper contrast differences, especially when we're doing DSO hunting. We can actually see a lot deeper than we would with one eye only. And those of you that even have standard binoculars, you can try this out if both of your eyes are fairly similar. Look through both and then close an eye and tell me the difference in what you see. It's quite profound. The scale enhancement has to do with the processing remnant of the way our eye brain system works. And this is another reason why binoculars in general, and particularly, becomes really significant when you start employing larger instruments under the night sky, because it's such a natural way to view things in general, because we're used to using two eyes in our normal life. Employing them under the stars that way, it's just so much easier on our eye brain system. We can actually concentrate on what we're looking at and not trying to do any sort of mental gymnastics and reorient and utilize processing power that would be employed in looking at detail to reorient the image and understand what we're looking at. Yes, we can train our eye brain system to do that. We often do that with telescopes, with either a Newtonian where it's inverting the image, or even with a refractor or an SCT with a star diagonal, where you have a reverse left to right image, or it might be slightly rotated depending on if you're using a gem mount. But still, not having to do that means it's just so much easier to pull things out of the celestial tapestry much more easily, and it's much more enjoyable, as was commented earlier. So this is like real science here. Now, this 1.4 will vary depending on how much weighting each eye gets. Some people have significant differences between their eyes. They may not quite get quite as much advantage, but it'll still be more than one in any case, so it's still worth doing. What this really translates to is if you had, let's say, a twin 100mm binocular, it's like looking through a 140mm instrument, a single 140mm instrument, all things being equal. And that's, you know, when you look at the difference in mounting and other capabilities, that's saying a lot. So it's really quite significant. And as was commented earlier, these things come to life when you employ your two eyes, and that there's no accident. This is what's going on. Very, very subtle, but very, very profound. And a lot of people don't realize it until they actually start seeing the advantages here. So just to recap on big binoculars in general, these are sort of the criteria I would recommend for big instruments. We talked about 3 to 5 millimeter, well, 4 was the median, is kind of a nominal range. Yes, you can get some instruments that have slightly smaller or larger exopupils. That's totally fine. But the 4 is kind of the sweet spot in that 4 range. Certainly with the twin binocular telescope designs, you'll have eyepieces that may get below 3. You might be at 2 or 1.5 sometimes. And in other cases, you might want to go very wide and you might be like at 5.5. Not a problem, but that 4 is sort of a sweet spot, mainly because of the design of the instruments. Eye relief, again, 16 to 22 is ideal if you have corrective lenses and unfortunately need to use them. I recommend if you can get away with not doing that, don't. Because anytime you put extra lenses in the I just use these for reading and looking at my computer. I'm one of the fortunate farsighted guys, so I can look at things far away, no problem, but close up I need to have. Since about 8 years ago or so, unfortunately, I have to use them now, but I would never use them in an instrument because I would have a tough time pulling out the maximum details. So if you at all can not use your glasses, I know it's a pain in the butt, let's say reading a star map and then going back and looking, but you get much better results. Anyway, if you happen to need them though, definitely go on the high side of that 22, maybe even 25 range if it's available. Definitely nice thing with these larger instruments, high quality prisms and fully multi-coated optics are almost the norm, but make sure that they're stated in the specifications, especially when you're getting a more expensive pair. You should expect to see high-end prisms and high-end coatings as standard equipment, not an option. This way, with the high-end prisms, they'll also typically be oversized because quite often the bodies, especially for the straight-through ones, they'll employ different barrel sizes at the factory and use the same body with the eyepieces, with the same eyepieces or oculars, and just put on different barrels to make the larger instrument quite often. And in that case, then you're going to definitely have round exopupils. You won't have any truncating or vignetting of your exopupil coming out. A lot of the straight through ones are rubber armored now. Quite a lot of them are. They should be at the very least weatherproof for a good pair, or in some cases are even waterproof, and they may even have the specs. Many binoculars are nowadays, but weatherproof is the bare minimum, I think, for most of them nowadays. So you want a quality construction because if they're not really well made, you will run into troubles down the road. You might get a misalignment of the barrels, or maybe they become loose and saggy, and now you're going to have trouble merging them to your eyes. So make sure that the construction quality is there. You want to have a good interpupillary distance range to accommodate a wide range of observers, especially if you have family members that you want to share the views with. And certainly you want to make sure that it's wide enough range for somebody, especially on the high side of either high or low side of this range. You want to make sure you have enough room to be able to accommodate your eye and nose and so on into the instrument. Otherwise, you're going to have challenges. I would recommend, if you can, to get the largest objective size practical for you. So if you are going to make the leap and you already have, let's say, a 15 by 70 pair, if you can get into a 100 millimeter pair and it's in your budget, that's a significant jump up, but it'll pay big dividends for you. If you're using, let's say, a 60 or 50 millimeter class instrument, a jump to even 80 would be really recommended minimum, because you're really going to be able to take full advantage of the capabilities. And it's still a light enough instrument, usually in about the 5 or 6, maybe 7 at the most pound range, that you can accommodate it on a wide range of mounts really easily without breaking the bank. If you can, not all of them are, but if you can, individual focus is preferred. Binocular telescopes by their design have helical focusers because you're employing different eyepieces. But with the straight through Poro style, I would definitely recommend if they do come in an option for individual focus, that's the way to go. It's absolutely fantastic to dial in the prime focus with both eyes perfectly focused. And it just forgetting everything else we talked about, when you get that just so focus, now you really have something. So it's really important. Not that the bridge styles where you set your diopter, but what happens here is we've got a fixed diopter setting. That'll accommodate me in general, but when I start to get through large temperature ranges, or let's say some areas of especially the northern states in Canada out here, what'll happen is at night, especially in the fall and early spring, we might be down close to freezing. So we start out at, say, maybe, I'm just trying to do the conversion for our American friends, but say 15 degrees centigrade, 60, and it might get down to, like, say, close to freezing, maybe 36 or something like that. That's a significant difference that you do have to refocus. But you got to remember that both of those objectives, or both barrels, need to focus together, but maybe not by a fixed amount that the diopter setting does. So having the individual focus just gets a little tighter. Doesn't mean that if you already have a pair that doesn't have that capability, that it's not worth using for astronomy. But certainly if you're looking at getting a new pair, I would definitely recommend that. Obviously, the decent apparent field of view is going to be in the 60 to 70 degree range. If you find that one is, let's say, pushing the low 50s, I would avoid it, because it just doesn't give you that immersive effect. And then you're going to have tunnel vision. So you want to be at least in that 58 to 72 range at minimum. And certainly 60 to 70 is quite typical here. Get the best you can afford, just like with anything else. Within reason, there's sort of an optimal quality value curve to price that, you know, you can spend double or triple, but are you actually getting triple the performance and triple the instrument? Maybe, maybe not. And it'll vary depending on the type of instrument you're looking at. I would say on average for these types of instruments, somewhere in the $500 to $800 range is kind of getting to that slope off on the curve, where if you spend 3 times as much, are you getting 3 times the instrument? Hard to say. If you're talking apples to apples, like let's say Poro Prism Binos to Poro Prism Binos, that's a pretty big jump. Let's say if I went from an $1,800 binocular to say a $600 binocular for the same aperture range, yes, the $1,800 binocular will probably most definitely show better quality images, but not that much more. That's the thing I'm trying to strike home here. So this is an example of a couple of my big binocular setups here. This is on the left-hand side here. This is my overworked 25 by 100 individual focus pair. This is the one that I did quite at this. I was doing Jupiter and Venus observations midday, and then I threw on my solar filters later and looked at the sun. This is using the overworked tripod with that carbon fiber adjustable stock. Sorry, just had a little bit of a brain stall there, and made it very easy to do observing. It was a lot of fun. We're talking midsummer. I was out in my chair just hanging out, and I thought, yeah, it's a nice day. I think I'm going to go and set these up and spend probably an hour and a half. Even just looking at Jupiter and Venus was a lot of fun that day too. So there's some really neat things that you can do. That's an exceptionally good pair of binoculars. I'll talk more about it in a couple of slides down the road. This is my APM 82 millimeter 45 degree binocular telescope. It's not inexpensive, I won't lie to you, but it was my first binocular telescope, other than most of mine have been the straight through Poro type. And I'm telling you, this thing is like my little sports car. I just love this thing. It's about 10 pounds, but the handle is really easy. You can see I've got a Picatinny rail on the top that I employ for a red dot finder when I'm not doing solar observing. There's no need to have the red dot on for that. And I just use the Bader full aperture there. A lot of fun. I find I can go through quite a wide range. This one was hyper tuned to about 100 power. So I have eyepieces that I can go to 100 power. I rarely go that high, usually 72 or 55. Jupiter at 55 power is really quite detailed compared to what you'd think it would be for an instrument of this size. That's what I was saying before. I was agreeing with how interesting it is when you employ a quality instrument like this. It just makes everything come to life. But I was really quite blown away when I started looking at planets with big binos higher than the 25 power, how much detail I could actually discern with it. It's quite neat. And then here's me waiting for, I guess there was a series of occultations coming through. I can't remember when this was taken exactly, but this is it on the same tripod as the other one on the fork mount, just waiting for dusk. And so I was just looking at the moon, waiting for it to get a little darker, but you can see how easy that is to set up. I can carry that out in one arm and just open up the legs, and I can accommodate the ranges of altitudes very easily. Really fantastic instrument. I know at the beginning of the talk, there was a photo of a guy with, that was actually the Overwork 65 millimeter binoculars that he had on the parallelogram mount. It's PM2. I bought this a couple of years ago as well. There's my APM 16x70s on there with a red dot finder. And I really like this mount. It's not cheap. It'll run you about $1,000 or so. But it's very, very smooth. Allows a wide range of different instruments to be mounted on it. As well, you can do both sideways viewing as well as over the actual arm, and the counterweights are inside the arm. So you can see here how they're mounted to allow you to slide them back and forth. And it's really easy to get a just so focus. You can also get, there's a pin lock on it. So when you're setting them up, most parallelograms will have a tendency to want to swing one way or the other. So the nice thing here is you can lock it down, move out the arm a little bit just to weight it down a little bit, and then drop your binoculars on, pull the pin, and then fine tune the balance, and you're good to go. So it's really nice having that lock pin. Comes with 2 cases and really high quality workmanship on there. I highly recommend it if it's something that you'd like to get into seriously. This will accommodate up to about an 11 or 12 pound instrument max, but certainly a 100 millimeter, 110, no problem accommodating that straight through or even in a binocular telescope range. So a lot of fun to be had with that. So like I said, there's the Overwork UBM is another one. The Orion Paragon, whether it's the HD or the smaller one, can certainly accommodate a wide range of mid-range binoculars as well. Overwork makes their PM2. I think there may be a couple of other companies. I even have a buddy that actually made his own. I don't know if I included the slide here. He did give it to me. Did I minimize it? Just bear with me for a sec. I should show you guys this if I can find it. Or did I forget to add it in here? I must have forgotten. My apologies. It's in a different talk that I gave. Anyway, he actually manufactured his own, and he just used aircraft tubing and some special counterweights that he got from working at like workout counterweights and so on, and actually made his own parallelogram with to allow for a pan head. So it has a good quality pan head. Use a surveyor's tripod. Probably ran him maybe half of what it would cost to get a PM1 mount, probably about $300 or $400 when you include the pan head, but it actually works very well. It's rock steady, not quite as lightweight as some of the other options, but I'm telling you, he can view in 50 or 60 kilometer winds with his 25 by 100s and have no trouble. I mean, it'll vibrate a little, but it won't be nearly as much of a problem as you would have with, say, a lighter weight tripod mount. So kind of neat. There's many manufacturers. Is by no means a full comprehensive list here. The big 3 are known fairly well. I'm going to be honest, I'm not as, over the years, I mean, I've owned many Celestron items, and I know some of their telescopes are very, very good, or certainly decent. As you get into the HD optics, they're very, very good. But when it comes to binoculars, unless you're willing to spend at least $300 or $400, I would say that some of the quality control on some of their lower end instruments is really a lot to be desired. I've seen everything from pretty decent optics, let's say in the Skymaster 15 by 70 pair, to absolutely abysmal and everything in between. And we actually had one of our club members buy a dozen of them at Christmas time. We'd probably spend $1,000. Went to, we have a store here called Canadian Tire, and he bought a dozen of these and could return them within 2 weeks. So he went out and individually tested each one and picked the creme de la creme and sent the rest of them and returned them back. But why should you have to do that with an instrument? Seriously, that's crazy. I think, I mean, obviously it makes sense if you want to take the time to do it, but he was very fortunate that he got the Christmas deal and had clear skies during that time frame. If the weather had gone south like it's been this year, he wouldn't have had the opportunity to do that, or if it was raining or cloudy or hazy or whatever. So you shouldn't have to do that. I think Orion on average of the big 3 is the better of the 3 for quality control as a rule. There may be exceptions to that as well, but I've tended to trust them a little bit more on those types of sport optics a bit more. Obviously Nikon and Fujinon and Canon have some exceptionally good binoculars. Canon's well known for its image stabilized. I own two myself. And actually, I don't own 10 binoculars. I actually own 13, by the way. I forgot to add 3 that I forgot to add before. So I actually have 13 pairs of binos. Soon to be adding a 14th big gun. I'll talk about that in a few minutes. But the Nikon and Fujis are very good. One of the problems, though, is that they're very expensive. And especially the Fujis being the gold standard in their 16x70 Polaris, as an example, exceptionally good images. But you're paying $1,800, $1,600. Some of them still fetch, even used, $1,000 in some cases. Certainly they deliver exceptionally good views, but that's a lot of bang for the dollar for an instrument like that. Apm Telescopes and Overwork actually compete very favorably against some of the camera manufacturers. And the nice thing is you have some other options too. Apm, I own several Apm telescopes, including the binocular telescope. They offer 2 versions. They rebrand under the Lunt moniker. So if you have looked on the Lunt page and see several binoculars, they're actually made by Apm as well. And of course, Overwork has been around for probably about at least 25, coming up on 30 years. And that's all they do is binoculars. And they have some exceptionally nice instruments for the money. I'll talk a little bit more about them in a moment. For the unibody bino telescopes, this is again by no means a comprehensive list, but Overwork certainly makes them. Vixen also makes some rebranded. I think the Orion ones are rebranded Vixens, and Celestrons might be as well. I could be wrong, but I think so. Apm, of course, makes their own brand, and I showed you my 82. I'm looking at getting a 120 millimeter this year. I had a really good tax return. I'm just waiting for the money to come into my bank account, and then I'm going to get a hold of Marcus Ludes and pull the trigger on one. So I'm really looking forward to looking at quite a few things this year with a twin 4.7 inch binoculars. That's going to be a lot of fun. Maybe I might even bag a Comet if I'm lucky. So anyway, these are by no means the comprehensive list, but these are ones that I would definitely trust. The binoculars from Vixen, though, you'll have to check, because I remember not only reading on Cloudy Nights, but in some other forums, the European ones, that some of the Vixen binocular telescope designs, like the 70 and 82s and so on, not all of them are weather sealed. The APMs are, and I think the Overworks are in that case. And these will run like anywhere from 2.5 to 3 times the price of a straight through instrument, but they do have the advantages of being able to use eyepieces. So again, if you're really thinking that this is going to be for you, definitely feel free to look into this option, but it will fetch you some money. I'm not going to lie to you, but they are fantastically fun instruments to use. I call my 82, like I say, my little Ferrari or sports car, because it's not only, it looks like it's just ready to view it right away. This is an example of some things that you can get through Overwork. So for those of you, and don't consider this an inferior choice by any stretch. The nice thing with Overwork being down in Ohio, for you friends down in the US, you can take advantage of free shipping that he has. We still have to pay for shipping up here. Really, really nice. I would say a good value instrument to get started on, let's say at 20 by 80. This is a fantastic price point. The nice thing with these instruments is that they are available with threading. This is an innovation that I haven't seen any other manufacturer follow suit with yet, is the 1.25" thread sizes for astronomical filters. Same thing with the 25 by 100 Deluxe. That's the one that was my first big binocular. And I just love that instrument. It's about an f5, so it's a little longer, but I'm telling you what, it has tons of contrast, really nice, fairly good flat field, and being able to use the 1.25" filters, you know, all the other advantages we were just talking about before. Now think about nebulas and being able to put on nebula and sky filters to enhance your DSO hunting. It just opens up a whole new world. And with the 2-eye view and all the other advantages, you're in for a real treat if you can do something like that. It's just a ton of fun. So this is really nice. And of course, with the binocular telescopes, whether Overwork or one of the other ones, you can put the eyepiece filters on and then pop them into the helical focuser and take advantage of this as well. So this is a really nice advantage with going to these larger instruments. You're starting to get these advantages really nicely. You can see how an 82 millimeter here is like 1450 US. That's quite typical. 1500 to 2000 is not whether you think it's expensive or not is irrelevant. That's the prices that I've seen for these new. It is quite a significant investment, but you can do a lot with them, and they do offer some really nice, enjoyable views for sure. But I'd say the best bang for the buck are the 2 outer. Those price points are very good, especially the 25 by 100. Absolutely fantastic instrument. I can't speak enough about it. And I actually had many years, about probably 3 years before I sold it to a friend of mine. And he's been using it probably 90% of his time, even though he's at a fairly dark site and he can pull out his 8SE. He just finds it's just so enjoyable doing binocular observing, and it's so convenient. You just can't get enough. So this is the kind of stuff I'm talking about. With the accessories, we talked a little bit about red dots when I mentioned my setups. These red dots, I would recommend trying to figure out a way to mount on an instrument, especially if you're getting into the 80 millimeter and above. Even my 16 by 70s, I use a red dot. I have a 4.1 degree field, so I've got plenty of field, but it just makes it so easy to point and aim, especially if I'm going to star hop in a region of the sky, or I'm just trying to go into an inner region of a constellation. It's much easier just to aim the dot right where I need to be, and then at least I'm in the neighborhood, and then I can move on from there. It just speeds up the process a little bit. I often won't need to use it much, but at least I have it. And certainly as you get into the larger instruments where you're in the 100 millimeter range, you've got about a 2 degree, that's like a 2 to 2.5 degree range with the 100 mil type. You're looking at in kind of a wide field telescopic range or medium wide field telescopic range. And quite often people still have a red dot or a finder scope for their telescope, even though they're using that wide a field. So again, I recommend doing that. And Overwork does carry these Picatinny rails to mount onto the stock, and you can get them on eBay and I think Amazon as well for often a little less than Overwork. But if you're not sure, feel free to send me an email and we can get you sorted out there. Another thing that a lot of people don't think about, especially on the side mounted, let's say like the UBM from Farpoint, it has a nice big L bracket, but you normally have a central slot on the bottom of the L where you would thread on your binocular stock or mount. I don't know about you, but I've had several times where I was a little nervous about doing that, because if it slid off the L, it would be banging my binoculars. Even if I had the arm fairly low, it still wants to go one way or the other on those ones that are non-locking. So I employed a quick mount release. They're about 40 bucks Canadian, so maybe about 25 to 30 US. But you could put this in lieu of the binocular mount. Then you put the binocular mount on the quick shoe release like you would for a camera. And then you just clip it in and out. And especially when it's dark at night and you're cold and tired after a nice night of viewing, the last thing you want to do is be worrying about your instruments. And that's usually when accidents happen. There'd be nothing sadder than having a 100 millimeter binocular fall onto the gravel or onto a grassy field on the objectives. That would ruin your night very much. So something to just consider as a kind of a neat accessory. I mentioned digital inclinometers, and these can be had for a very low price point. I use them on a lot of my binocular mounts just so I can be able to tell where I'm aimed when I'm doing daytime planetary mostly, or early dawn dusk where it's not necessarily naked eye visible yet. But sometimes even if I'm having a tough time finding a more elusive DSO, I'll look on Stellarium and see that it might be at 45.6 degrees or something. And then I'll just dial into that area with my binocular, aim in the region of the sky where I'm supposed to be, and just pan back and forth a little bit. And then usually it'll pop into view. So it's mainly as an observational aid for the most part. Not to mention you can use it for other applications as well, like leveling your mount and evaluating your latitude setting on a gem and so on. So it's really handy device, or altitude indicator for a Dob even too. Other accessories, we talked about solar observing, of course, and I do recommend the Bader, whether you get a make your own or get one of the binocular, the ASBF ones. That's the finest white light solar image that you'll see shy of getting a Herschel wedge. Because of a binocular, you can't do a Herschel wedge. So you have to employ these types of full aperture filters. I find the glass ones inferior in general, unless the high-end ones aren't, but then they're optically figured to at least 8th wave or better usually. But certainly putting a pair of these on is a much more cost-effective way to go. And you'll get beautiful views of the sun, especially when you're trying to follow an eclipse or look at a lunar eclipse even, well, not lunar, I guess, solar eclipse, or maybe even a transit, although I think the next transit we're going to see with Mercury isn't until the 2030s. So I guess we have a little time to wait there. Of course, if you have a binocular telescope or a unibody system, you're going to have to pair up binocular eyepieces or twin up what you have in order to employ them in the instrument. So that does add to the cost as well. Just be mindful of that. These ultra flat field APMs are fantastic, even as a telescopic instrument. So if you're looking for some really good high contrast, reasonably priced, really flat field of view contrasty eyepieces, these UFFs are fantastic in the telescope as well as in a binocular telescope. So worthy of consideration. The Eyepiece filters, that gives you about a panoptic, just shy of a panoptic field of view, by the way. Eyepiece filters, of course, I mentioned before. I do recommend getting polarizing filters if you're getting ones to thread onto an eyepiece or ocular, like with the Oberworks, because you can darken the background sky, and especially when you're doing lunar, let's say late morning lunar or early dusk viewing on the moon, you can darken up the sky quite a bit and see a lot more detail on the moon with the binoculars, not to mention dig out the planets a lot easier too. So just before I close up here, this is, some of you may already know of this fellow, Steve Tonkin. He's a friend of mine for many years back. He's been doing outreach for somewhere about as long as I've been observing. He's a little older than me, but at least for coming up on 5 decades of outreach in general. And his main focus has been binocular outreach. He's got a great website. His newsletter is really nice because it'll go on a monthly basis, show different targets with different apertures as applicable. So if you have a 50 millimeter pair, he'll outline some of those, and then he'll mention, but if you have 100, you'll have a better chance of seeing this, this, and this. So it's definitely a neat newsletter to get. A lot of good objects. Sometimes there's some repetition from month to month if they're still in view or prime viewing time. His book, Binocular Astronomy, is worthy read. He goes through a lot of things that I've talked about today, as well as talking about optical parameters and considerations on binoculars, what's considered acceptable and non-acceptable, as well as the mechanicals and other things. And he's got quite a nice section on binocular optics in general. And so it's a worthy book to have if you're interested in learning more about how binoculars work, or maybe even want to adjust yours in the future. That's pretty brave, but you can do it in some cases. So definitely a worthy book to consider to have on your shelf. So in closing, I just want to remind people, which type of observer you'd like to be. I know this is a little bit overkill, and I'm sorry if it's insulting of you folks, but I certainly don't want to be praying to the sky gods when I'm, well, maybe, but certainly not when I'm taking a little desktop dog. She's down on the ground there. But this poor fella here, this is normally, again, aimed at newer observers, but even as more seasoned observers, we still have to have a shot to Polaris and know where we're aiming, or have a dedicated observatory already set up or something like that in order to just at a moment's notice go out and view. Nice thing with these cool cats here is they don't have to wait for darkness. They don't have to wait for a view of Polaris. It doesn't matter if Polaris is behind the house. You're just out and viewing and in a moment's notice. And that's the really cool fun factor about binoculars, and especially big binoculars. You're out viewing right away, and it's a lot of fun. And it's this fun factor and the experience that you can't get with any other type of observing instrument that I hope I struck home with you guys today. So whichever way you decide to go, whether you decide to stick to your handheld pairs, which I've got lots as well, and I use them very frequently as well, or you go, hey, Darren, you're onto something here. I think these big binoculars might be a lot of fun. Whether you do either way, I think you'll agree that binoculars do double your fun under the stars, and prepare to be amazed at your first glance through a larger instrument. It's just absolutely amazing. You'll be absolutely overwhelmed. Thank you very much for your time today. This is my email address on the slide there. I'll leave that for everybody, and I'm open to any questions. Feel free to ask away.
Fantastic, Darren. That was a great presentation. Again, if you'd like to ask a question, remember to unmute yourself, or if you prefer, you could put it in the chat and Wayne or I will read that out.
Yeah. Darren, I have a question. I'm thinking of doing solar am I better off to just get some filters for a pair of binoculars rather than a dedicated pair of solar?
Darren, you're muted.
It didn't work here. Sorry about that. Okay. So if I understand your question correct, I did hear the question. So going solar, what size aperture of instrument do you have for binoculars?
I don't have either.
Oh,
I don't
okay.
have a pair. So I'm a rank amateur in the sense of a binocular. So but I had seen a pair of solar binoculars, and I said, well, that makes sense rather than just having my telescope. But then after your presentation, then I'm thinking, well, maybe I should do a regular upgrade to some kind of a nice pair of binoculars.
I think well, it really depends on how much solar you're going to do. If you have a decent telescope, I mean, a full aperture solar filter will definitely let you dig a little closer, and you'll see finer detail. But it really depends. I mean, for a lower investment, if you're thinking of getting a large binocular just for general observing anyway, the nice thing is with the binocular filters, you've doubled up on your instrument very quickly. And there'll be days where you might have a nice sunny morning, but then it's going to be cloudy in the afternoon. It may not be practical to pull out a larger telescope, depending on what you have right now in your arsenal. And again, it may just not be very convenient. The other nice thing with the binoculars is if you, let's say, needed to focus to infinity to do, let's say, planetary observing, you could dial into the sun, look and see if there's anything going on, move off, and now take off your filters. And now you're looking at Mercury and Venus and maybe something else that just come out of the sun glow, if it happens to be bright enough at the time to be able to fit into the view during the daytime.
That's what I'm looking for, is convenience. I know a friend of mine in the club here, he has a nice Coronado solar telescope. Well, I can't afford that kind of monies. I just want to be able to go out and look at the sunspots that are now starting to crop up.
Right. I would say your best bang for the buck, if you're looking at getting into this, do you have a decent, like a tripod and at least a pan head or mount that is fairly heavy duty right now?
Yes.
Okay. So it would accommodate, let's say, a 10-pound instrument, okay, or in that range?
Yeah.
So your best bang for your buck is the 25 by 100s. By overwork, those IFs that I was talking about, and get a set of, you'll have to get a set of 100 millimeter aperture solar filters fit on there, and a pair of twin polarizers as well would be useful. It just drops down the brightness a little bit, and you should be able to dig out a ton of granulation there, and you'll have a lot of fun. It won't be an H alpha system, no, but you'll be able, yeah. But I think there's a couple of, well, we had that one in 2017. That would have been a great. See, the nice thing with binoculars here with the full aperture deal is, so you're looking at this eclipses that's going along, then it gets close to totality. You pop these off, you're dialed, you just tweak the dial, you just tweak the focus a tiny bit, you're dialed in, and now you can see the totality. And then as it starts to get close to coming out, you pop them back off. And it's a quick setup that you can really get some really good views from. So I think from a portability and convenience standpoint, that would be the way to go. I think you'll have a lot of fun with the instrument outside of just the solar observing as well. And, you know, the first time you train them on the moon, you're going to be blown away. I'm not kidding you. It's really funny. I mean, you're looking at a moon that's, say, at 25 power, and you're thinking, okay, that's pretty small. But when you start looking at the moon at 25 power with your two eyes, it's a totally different experience. So if you have somebody in your local club that has a big pair, just see if you can even just take a peek just to get an idea what I'm talking about. But I would say that's a good bang for your buck. You could even do an 80 mil if that's more cost effective for you. But that 25 by 100, you're really digging a lot deeper. And I think you'll have a lot of fun with an instrument like that.
Okay. Well, thank you very much. And thank you again for the presentation.
Oh, my pleasure. Good question.
Yep.
Go ahead, sir.
Sorry, Darren, we have a question in the chat from Marcellus, I believe, who asked any comment on constellation binoculars with a book, Bino Scout from Germany.
Constellation, is that a brand? Constellation Binoculars? I'm assuming that's a brand.
Ultra wide field.
Oh, ultra wide field. Okay.
Oh, Constellation, I see.
Okay, I see what you're saying now. Yeah, okay. I was just trying to get an idea of that. Okay. So what's the field of view on those?
Claimed or by use? Usually they claim in
well, why don't you tell us both, because that says a lot right there.
Okay, well, I've got the Orion ones, which I enjoy very much.
Right.
They're claiming in the 30s, but I can just fit the Big Dipper, the bowls at the end of the handle.
About a little over 25.
24.
Just, yeah,
23, 24, yeah.
Well, those are actually really interesting. We had a couple of our club members ask about this on one of our RASC Winnipeg forums as well, because Vixen makes one, and that's probably the one you've got. Or sorry, Orion has its own, and then Vixen makes one as well. I think it's a 4-power instead of a 2-power or 2.3 or whatever it is. Anyway, those aren't really technically binoculars as a rule. Like, they're kind of great. So it's kind of, but I've never looked through a pair like those, but I hear it's a totally different experience for doing kind of immersive, ultra wide swath views. It's supposed to be quite the thing. I know one of our club members had purchased one over Christmas. I think they got him as a Christmas gift. We haven't had much sky amenable out here in the area. Winnipeg's been kind of just getting pummeled by cold and wind and snow. And, we do get a couple of nights where it's really beautiful, but it's just too cold to practically view. I mean, I consider myself not a very good polar bear anymore, I guess. So, when it's minus 30, doesn't matter whether you're Fahrenheit or centigrade, that's cold, and it's not fun for more than about 2 minutes just to go, okay, there's the moon, I'm going back in. I just can't, it's too hard to handle. But I would love to take a look. I'm thinking of getting a set of those myself. I've heard good things. I did look at the specs on the Orion ones. They have I think it's an 8 millimeters of eye relief. Does that sound about right on those, Marcellus?
You really got to have them in snug.
Yeah, so it's kind of in that 10-8. Yeah. So you do that. Definitely that wouldn't work for somebody that needs corrective lenses to do observing, right? It would be too close. My comfort factor, I've got very sensitive eyes. So anything less than 10 starts to get uncomfortable for me. I think that's right at the threshold there. But I'm thinking of, once I get a chance to look through the other members, I'm going to check them out. But I hear it's a lot of fun. Certainly probably worthy of, especially when you get to a dark site where you can get like swaths of Milky Way or those extended. Yeah. I'm sure it's just amazing. The rift must be just fantastic in those.
I've also heard of people using old teleconverters, or like, I think Canon or something like that, teleconverters with an eyepiece, and joining them together to make their own constellation binoculars.
Yeah, I've heard of that too. Yeah, and I think they can be used depending on the specs on them. I haven't really delved down that way as much, because I'm more of a traditionalist with the actual prism binos, but I can see an advantage to having those. I know what you meant now when you said constellation binoculars. Just took me a second to get the idea, but yeah, those are quite neat, and I think we're going to see more and more of those types of instruments coming out over time, because using your two eyes and having such an expansive field really does give you an extra depth to the sky, from what I've heard on reports and so on. So I've heard good things about those. So awesome. Definitely email me on your experience too. I wouldn't mind maybe having you talk to you a little bit more about your experience with your pair. So you have my email there. If you need it again, I can post it back up. Any other questions, folks?
So Darren, what about dew control? I assume it's similar to what you do with the refractor, but ×2.
Yeah, I guess that's true. Technically, you saw in the twin binocular telescope that I had, that 82 millimeter, it has integrated dew shield. So I haven't had nearly the issue with dew issues on the instrument. I'm a big fan of keeping my optics very clean, regardless of whether it's a refractor or a SCT or whatever. And I find that your threshold of getting dew and condensation is much less the cleaner the optic, because you don't have nucleation sites. Doesn't mean you want to be crazy about keeping things clean, but like that big overwork 20 or 25 by 100, it doesn't have sliding dew shields. So you could make something out of like super slider and Velcro, or you could maybe get a smaller. I think you can even get. I'm not sure though if. I'm just trying to Astro Zap or whatever those wrap around. I don't know if they make them quite that small, do they?
I think it
4-inch?
wraps on itself, so whatever the size is, you could still.
Yeah, you could
them.
probably double them up across. Like you could get an 8-inch one or a 10-inch one and just make it flat instead, so it'd be kind of like an oval shape. The only thing is that would make the instrument a little heavy. Those AstroZap ones are fairly heavy. You could probably do something similar for a fraction of the cost with like a super slider type material or a thin piece of plastic sheet, as long as it's flexible, and then maybe put some felt on the inside where it's going to come into contact with the body of the binocular and some Velcro, and you'll be good to go. Yeah, I haven't had too many problems out here. Usually when I'm out observing, by the time it gets to the point where you're getting dewed up, you're pretty pooped, right? We usually get out fairly early, and once you've done 5-6 hours, I'm pretty tired by then.
Right? You're lucky. We get dew at sundown here.
Oh yeah, but we have too. So in the late fall we do sometimes, But you guys are a little bit more humid than us, right?
Yeah.
Even in the summertime we get high humidity, but it stays around a lot. Like it won't vary quite as much as what you guys have. So in your case, you could even do an let's say a Kendrick dew heater as well if you wanted to. I guess the only challenge there is to make sure that you don't have too many tube currents. You wouldn't want to run that excessively unless you're really, really plagued. Do you find just right at dusk it gets the worst and then it kind of flattens out after that?
It starts at dusk.
And it just
sometimes
the
equipment is just swimming.
Okay. Well, definitely in that case, I would definitely make a dew shield for sure if you have a pair not equipped. Otherwise, you're just fighting dew all the time. The nice thing with the binoculars, though, is at least you can orient them easily on an alt-az mount. You can point them down if it's getting really bad. And most of these larger pairs, like I said, are either weather or waterproof. So the water incursion isn't usually an issue. You just wipe them down with a cloth or a towel, clean one, and then you're good to go once they've kind of... I know that I've only had one challenge. We were at a star party a couple of years ago in Manitoba here, and it wasn't right at dusk, but certainly by 2 hours after dusk, everything was... I mean, I had water dripping off not the optics, but the body. Yet my optics were still relatively clean, but my eyepieces were fogging up to beat the band. And even if I pulled away and tried to, wave my hand or tried to just get air flowing, it was becoming a losing cause. So
yeah, sure.
But the same considerations that you would do with a refractor. Certainly. That's my long-winded answer. Sorry about that, Mark.
Oh no, that's great. That's good information.
Any other questions?
I have one more question.
Sure.
So you see several of us wear glasses, and some of us take glasses off when we're looking through our scopes, and some of us don't. So how do you do it? I noticed you wear glasses.
I just take mine off and I use my two eyes without glasses. I only use these for reading. Reading and screen stuff.
Because you said you're farsighted.
Yes. Right? So for the unfortunate few that are nearsighted or that need to wear them for the wide ranges, you'll have to be careful too, because if you've got, let's say, like these are, I can see to about maybe 30 feet to 2 feet or 1.5 feet. So anything beyond that makes it really difficult for me. If you have progressives, if you have bifocals, you're okay. But if you have progressives, like if it goes to almost infinity and then to near, then you're okay. But if they're progressive, that could be a bit of a challenge with the bigger binos, especially. And you probably find the same thing with smaller pairs. You'll have that just so position, but you have to get it just right. And more than likely, you're going to need a larger or a longer eye relief. You probably want to be in that 22 to 24 range to comfortably get the thing accommodating you, right?
Right. Okay.
So those are the kind of things you're going to have to look at on the long term if you're going to do this kind of thing.
Okay, great. Reg, were you raising your hand? Oh, I thought he was.
Yes, Reg.
I thought he was raising.
Or maybe he's saying no, I don't. Or maybe he's agreeing with me. I'm not quite sure. No, I have my friend James, if it's okay. James Fast, are you still in the gang here? I don't know if he fell asleep.
Yep, he's here.
I am. Okay. Nope, I'm here.
Okay. There was a few people that didn't come on board earlier. James is a fellow RASC member from Royal Astronomical Society of Canada, member from our Winnipeg branch. Newer observer. He's got a little over a year's experience now, and he's had the pleasure of looking through several of our club's Big Binoculars, and he just recently purchased his own. And I'd just like him to share some of his comments, because you know, I'm a seasoned observer, but having a newer member and a seasoned member kind of gives you a little bit better spectral indication of, you know, what to expect. I think that's probably a good idea. So if that's okay with you, Mark, can James just make a couple of quick comments? Okay, thanks.
Perfect. Awesome. Thanks, Darren, and good evening, everyone. Yeah, I've really just wanted to emphasize and share that for those who haven't had the opportunity to look at the skies with binoculars, Darren isn't full of horse hooey and the amount of fun that you can have. It was mentioned earlier about, you know, the double cluster in Perseus, how immersive that is, and there really is nothing like looking at those open star clusters and larger DSOs, right? Andromeda and Orion's Nebula, and, you know, even multiple, you know, M81, M82, the Leo triplet. In a mid-sized big bino, I'm running a 20 by 80 APM standard, you know, probably $700-800 in that range. But what you can see is just unbelievable with the two eyes, but also planetary, right? I mean, I can see last summer seeing the rings of Saturn separate from the disk, right? Or watching the moons of Jupiter dance with each other and merge, right? What did we say, Darren? We saw them to about 3 seconds.
You were just shy of 3 arc seconds there with your 20 by 80s. Right? Like Europa and Io were just shy of.
And and then they merged, and then about 10-12 minutes later, all of a sudden you could see them resolved again from each other. So tons of fun. Moving on, and I will mention just briefly another resource. I know Darren mentioned one, but Gary Soronik, which he mentioned before, has this book called Binocular Highlights. I'll just hold it up there like that if you could see that. This is like your Messier catalog for binoculars. Absolutely thrilling just to take this thing and take it with you with a pair of binoculars on a tripod and spend an evening just on the back deck here in the city. It's just tons and tons of fun. I have 2 telescopes, a 6-inch refractor or a reflector and a 80 millimeter refractor, and I still use them from time to time. But man, I tell you, if I just have 10 or 15 minutes, I can spend all that time looking through binoculars, no setup at all. So lots and lots of fun.
That's great. I think that's one of the selling points is you can just leave them set up and take them out and use them. I don't have anything like that right now that I can use.
No, neither do I.
Wayne here has the LX90. How long does it take you to set that up? It's a long time.
20 minutes.
20 minutes, yeah.
The funny thing with this whole deal is, like even with the big binos, a lot of the fun for those that really have a passion for visual astronomy, the more you view, the more fun it is, and the more you're inclined to go out and view. And so these kind of instruments, because of their ease of setup and what they do deliver, is kind of fill a unique niche between, you know, the other two extremes, but sort of a synthesis or whatever you want to call it between the two. But yet they have the advantages of the smaller pairs in some cases, and some of the other advantages I was talking about. You find yourself going out and looking more, and it's just being connected to the sky that much more, and having the convenience of, you know, narrow windows of 15-20 minutes sometimes, or a half hour. You're still not losing a lot. Whereas if you have a big instrument that's sitting in the closet and you haven't used it for 8 months, and then you're waiting to get out to do some stuff, you're less like, you start getting rusty too. Let's face it.
Yes.
Right? It takes you a while to get back into the saddle. And then by the time you get there, it's time to pack it up again, or it's less convenient because the weather windows have closed and things like that. So some real benefits to having new instruments like this.
Well, I'll admit, for years I was a scoffer, but I never had anyone explain it to me the way that you did. And honestly, I watched your presentation to the Toronto Centre a couple of times, and I thought, man, I think I'm really missing something here. Something I got to try.
I appreciate that. Yeah. And I had I known I was going to have so much fun with big binoculars, I'm kind of kicking my own butt, because I've been doing it for about 9 years now. I have 48 years under the eyepiece. And I know it was, well, of course, things have changed a lot in the last 20 years. I mean, a lot of instruments have become more readily available. I mean, I think we had reflectors, maybe some very expensive small refractors, And then SCTs were really the three instruments back in the 70s, early 80s, maybe a small Mac like a C90. And that's about it, really. And then, in the last 20 years, I mean, there's been an explosion of available instruments, right? So, but even 20 years ago, had I known I was going to have this much fun, I'd have bought a big binocular back then. I'm kicking my own butt. And I've always enjoyed binocular observing in general. So, but thank you for your comment on that. I just really tried to kind of synthesize all the advantages and the things. There's some subtleties like the eye-brain system and how the twin eyes work as dual detectors that I think aren't really appreciated as much with binocular astronomy in general. And I think that's a big win for a lot of people when they don't understand that. And especially newer observers, like I said, I've had lots of people that join our club and I say, hey, what do you got for instruments? And they go, oh, just a pair of binoculars. Like it's some, oh, really? You're the poor boy now? It doesn't, I mean, they're very powerful instruments if used properly.
And they're not for poor people. It doesn't sound like.
No.
Any other questions?
I'm good. Thank you again.
All right, great. Yeah, thank you very much, Darren. We appreciate it. And I guess we'll wrap it up here, and I'll have the recording on YouTube sometime tomorrow morning. Okay.
Sounds good. And for those of you that think of some questions, or those of you like Felix and a couple others that asked some questions earlier that need me to answer some more offline, my email I think you already have, but should I just pop it up again one more time for everybody?
Sure
just
thing.
to make sure they have it. Let me just share my screen here. I don't know if I did that yet. Is the screen still shared? No, it isn't.
No, it's not. You can put it in the chat if you want, Darren.
Oh yeah, let me just do that. Sorry, I forgot we had the chat going here. I'll just do that right now. I'll just type it in right this minute here. Okay. There we go. That's me. So feel free to email me if you think of something later that, or if you have a question about a particular pair. Granted, I don't have experience with every pair under the market or under the sun, and I will admit I have some favorites, and some of them I certainly showed, but I'll try to be as unbiased as possible. And if I don't know, I might have some resources that I can steer your way if there's one that I'm not familiar with, although I have done quite a bit of research into this over the last few years, just because of this being a unique segment of the hobby for people. Thank you, Mark. Appreciate you inviting me today. Thanks, guys.
Yep. Thank you, Darren. We appreciate
you guys
being here.
Warm.
Okay. Yeah. Thanks. Thanks, everyone.
Yeah, I'm going to end it, Mark.
All right.
Can you stay on for just a second, Wayne?
Sure, Paul.
Okay.
Okay. This is real quick. I don't know if you've seen the